Hey, this is Prealgebra. Here are 6 puzzles that will test your calculation skills. How many can you solve? Puzzle 1. A bat and a ball together cost $1.10. The bat cost $1 more than the ball. How much does the ball cost? Many people get this puzzle wrong because they focus on the detail that the bat cost $1 more, and they instantly think that the bat must cost $1 and the ball costs 10 cents. But this cannot be the solution because $1 is only 90 cents more than 10 cents, and we know the bat cost $1 more than the ball. So let's solve this problem carefully. Let's say B is the price of the ball. Then the bat costs $1 more than that, so that will be B plus 1. The total cost is $1.10. We now have an equation. We have 2b plus 1 is equal to 1.1. Subtract 1 from both sides and divide by 2 to get that the ball has a cost of 5 cents. And that would mean the bat has a cost that's $1 more, which will be $1.05. And together, the bat and the ball will cost $1.10. So the ball costs 5 cents, and that's the answer. Puzzle 2. This is said to be one of the hardest questions on the American SAT exam. If 3x minus y is equal to 12, what is the value of 8 to the power of x divided by 2 to the power of y? Is it 2 to the power of 12, 4 to the power of 4, 8 to the power of 2, or D, cannot be determined from the given information? Many students look at this and it's just an intimidating problem. But it's all about exponent rules. So 8 is equal to 2 to the power of 3 because 8 is equal to 2 times 2 times 2. So we have 8 to the power of x divided by 2 to the power of y. This is equal to 2 to the power of 3 raised to the power of x divided by 2 to the power of y. We have a positive exponent to a positive exponent, so we can multiply the exponents. The numerator is 2 to the power of 3x, and the denominator is 2 to the power of y. We can then subtract the exponents so that we have 2 to the power of 3x minus y. But we know that 3x minus y is equal to 12, and therefore the correct answer is A, 2 to the power of 12. Puzzle 3. Here's a problem that goes viral every single year and starts a lot of arguments online. I bought a cow for $800. I sold it for $1,000. I bought it again for $1,100. I sold it again for $1,300. How much did I earn? This problem is not just some viral math problem that people argue about, but it has actual financial value. Imagine instead of this story being told with a cow, that this story was about 1 share of the cash cow NVIDIA. What would you have to report as your earnings on this stock? So let's work it out. So here, you bought a share for $800 and you sold it for $1,000. This is definitely a gain of $200. You then bought a share for $1,100 and sold it again for $1,300. This is another gain of $200. So the correct answer is you earned $400. And that should be the end of all the arguments. But there are many people who point out one more thing. When you say you earned $400, there's one more step that's involved. You sold it for $1,000 and you bought it for a higher price of $1,100. So this would seem to be $100 that you lost, which would reduce your earnings, so that would only be $300. So if you do want to account for this step as a loss, does it actually net out to $300? Let's see. Let's go through the steps. So let's say you sold it for $1,000. That's definitely plus 100. Now you bought it again for $1,100, and that will be minus 1,100. So you definitely do have a loss here of $100. But now you've accounted for these two steps, and there are two steps that are remaining. You bought a share for 800, that'll be minus 800, and you sold it again for 1,300, so that'll be a plus 1,300. When you take these two steps into account, this will be a gain of 500. So how much will you earn when you take the net of all these transactions? It will be 500 minus 100, or minus 800 plus 1,000 minus 1,100 plus 1,300, and that still nets out to $400. So without a doubt, you did earn $400. Puzzle 4. If a hen and a half lay an egg and a half in a day and a half, how many eggs would one hen produce in one day? So here's what many people think. You have a hen and a half, which is 1.5, an egg and a half, which is 1.5, and a day and a half, which is 1.5. So if you scale this down from 1.5 to 1 hen, you scale the days down from 1.5 to 1, how many eggs would you produce? It would seem natural that you would scale this down, and this would be 1 as well. But it is not correct. The correct answer is not 1 egg would be produced by 1 hen in 1 day. So what is the correct answer? The correct answer is actually 2/3. So why is there a different fraction over here? Let's see why. We will work this out with dimensional analysis. So we need a formula that takes the inputs and relates it to the outputs. So here's a formula we could have. We have the number of hens times the number of days times the rate at which they are producing eggs is all going to be equal to the total number of eggs. So we start out that 1.5 hens in 1.5 days times the rate will be equal to 1.5 eggs. So all that remains is to solve this equation for rate. We can cancel 1.5 on both sides of the equation. So 1.5 times the rate is equal to 1. Divide both sides of the equation by 1.5. 1 divided by 1.5 is the same thing as 1 divided by the quantity, 3/2, which will then have a reciprocal that's equal to 2/3. And that's the answer. The rate will be 2/3 eggs per hen per day. So the answer is that 1 hen in 1 day would produce 2/3 of an egg on average. And that's the surprising answer. Puzzle 5. Here's an interesting visual puzzle. We have balls arranged in 4 different layers in a pyramidal shape. How many balls are in the picture? They say 95% of people get this wrong. So let's take a closer look at the picture. The important question is, what kind of pyramidal arrangement is it? If we look at this bottom layer, 1 ball is right in the front, and then we have 2 balls that are adjacent to it. Is the bottom layer in the shape of a triangle, or is it instead in the shape of a square? This will, of course, make a big difference in the total count of the balls. So how can we distinguish between these two different arrangements? Let's take a look at the triangular arrangement. The 2 balls, 2 and 3, are exactly tangent to each other, and they're touching. There's no gap between them. But in the square arrangement, there is gap between balls 2 and 3. If we take a look at our picture, there is exactly a gap between 2 and 3. So this suggests that the pyramidal shape will actually have a square pyramidal base, and each layer will be a square. So this will be the correct arrangement of the balls. So now we know that each layer is a square arrangement of balls. The very top layer will just have 1 ball. The second layer will be 2 by 2. The third layer will be 3 by 3. And finally, the last layer will be 4 by 4. So the total number of balls will be the sum of the squares to 4. 1 squared plus 2 squared plus 3 squared plus 4 squared. And this is equal to 30 balls. And that's the answer. Puzzle 6. Here's a legendary puzzle. We have a sum written with letters instead of digits. The problem reads, 40 plus 10 plus 10 is equal to 60. And it's a magical thing that this is a true equation. Each letter represents a different digit from 0 to 9. Solve for each letter. I thank Jordan Goff for the suggestion. So let's work through this problem step by step. A natural starting point is the very right column of digits. Now, what's the maximum value for 3 digits being added together? The maximum value for a digit is 9, and 9 plus 9 plus 9 is equal to 27, which is less than 30. So when we add 3 numbers, we know the smallest we're going to get is 0, and the largest we're going to get is 27. So the sum of y plus n is y plus 2n, and we know this ends in a digit y. So we have 3 possibilities. Y plus 2n is equal to y plus 2n is equal to 10 plus y, or y plus 2n is equal to 20 plus y. Let's start with the last possibility. Suppose y plus 2n is equal to 20 plus y. Subtract y from both sides so that 2n is equal to 20. But then n would have to be equal to 10, which is greater than 9, which is not possible. So this possibility can be eliminated. So let's instead suppose y plus 2n is equal to 10 plus y. Subtract y from both sides so that 2n is equal to 10, which means n is equal to 5. Now, if n is equal to 5, we know that y plus 2n is equal to 10 plus y, so we will have a carryover of 1 to the next column. We can now analyze the next column, and we have the equation that 1 from the carryover plus t plus e, which will be 2e, will end up with a last digit of t. And we know the carryover can either be 0, 10, or 20, because the sum of 3 digits with a maximum value of 9 could be 27. Even if you take the carryover of 1, you're not going to get more than 28. So subtract t from both sides of the equation. So we have 1 plus 2e is equal to 0, 10, or 20. Subtract 1 from both sides, and we see we have a problem. All the numbers on the left-hand side will be even numbers, because 2 times a number will always be an even number, and the numbers on the right-hand side are odd. So there's no possible value of e which will make this possible. So there's no way that this could possibly work, which means we can eliminate this entire possibility. So we are left with one possibility, that y plus 2n is equal to y. Subtract y from both sides so that 2n is equal to 0, which means n is equal to 0. So we have solved for the value of one of the letters. Now there are 10 possible values for the letters, going from 0 to 9, and let's keep track that we know that n is equal to 0. Let me also write this value into the equation so that we know what we've solved for already. Where do we go from here? So let's go to the tens column because we have a very similar sum. We have t plus e, which is t plus 2e, and the resulting sum is something that ends in t. So t plus 2e is equal to something with a last digit of t, and we know we're going to have a carryover of 0, 10, or 20. Now we know we can't have a carryover of 20. That would be when e is equal to 10, and e at most can be equal to 9. So the two possibilities are a carryover of 0, where e is equal to 0, or a carryover of 10, where e is equal to 5. But we can't have e is equal to 0 because n is equal to 0, and each letter represents a different digit. So we eliminate this possibility. So the only possibility that remains is e is equal to 5. So we must have a carryover of 1, and we know the value of e. So let's mark the value of e, and let's put that into our sum. So the next place we will go is the very left two columns. And in particular, let's go to the column which has O and I. We know that O and I are different digits, so there must be some carryover from the previous column. What could the value of the carryover be? Well, the sum of three three-digit numbers is less than 3,000. So we know the carryover has to be 2 or 1. We know it can't be 0 because we have some carryover. So the only possible values of carryover are 1 and 2. Now, if we have a single digit and we have a carryover of 1 or 2, how can we get it so that we have carryover? Well, we have one possibility, which is O plus 2 is equal to 10 plus I, or we have O plus 1 is equal to 10 plus I. But if O plus 1 gives carryover, the only possible value for that would be 9, and we would have 9 plus 1 is equal to 10. But in that case, I would have to be equal to 0, but we know that's not possible since n is equal to 0. So we can't have this possibility. So we must have a carryover of 2. Now, if we have a carryover of 2, we could have a plus 2 is equal to 10, but that's another problem. We can't have I is equal to 0. So it must be that we have 9 plus 2 is equal to 11. That would mean that O is equal to 9 and I is equal to 1. So we solve for 2 more digits and this carryover. We also know there's a carryover of 1 to the very last column. So let's mark down that we have O is equal to 9 and I is equal to 1, and let's substitute that into the sum. We will now proceed to the third column, and this is probably the hardest part of the puzzle. So we know we have a sum 1 plus r plus t, which is 1 plus r plus 2t, is equal to something that ends in x, and we know the carryover is going to be 2. So 1 plus r plus 2t is equal to 20 plus x. But we have some restrictions on these digits. Because O is equal to 9, we know that r and t cannot be equal to 9. Their maximum value will be 8. We also know that x cannot be equal to 0 or 1. It has to be greater than or equal to 2. So if x is greater than or equal to 2, 20 plus x will be greater than or equal to 22. Therefore, 1 plus r plus 2t is greater than or equal to 22. Subtract 1 and 2t from both sides of the equation, so r is greater than or equal to 21 minus 2t. So what's the smallest possible value of r that we could consider? This will happen when we're subtracting the largest value from 21. Now the largest value for t will be 8, and so we'll try to subtract 8 from that. So r is greater than or equal to 21 minus 2 times 8, which equals 5. But we know that e is already equal to 5, so it has to be that r is greater than 5. So we only have 3 possible values. R must be equal to 6, 7, or 8. But now that we know the 3 possible values for r, we can also deduce something about t. So going back to this equation, 1 plus r plus 2t is greater than or equal to 22. We know that 2t must be greater than or equal to 21 minus r. And we know that r can be 6, 7, or 8. So if we subtract the maximum value of 8, we then have that 2t is greater than or equal to 13, which means t must be greater than or equal to 7. So the only possible whole digits for t would be 7 and 8. So we know that r has to be 6, 7, or 8, and t has to be 7 or 8. Now what can we say about f and s? We know that 1 plus f is equal to s. So we only have some possibilities. Suppose that we have f and s are in 6, 7, and 8. We would need the pairs to be something like 6 and 7 or 7 and 8. But we know that we must have 2 values of r and t in 6, 7, or 8. So if 2 of the values are already taken, there's no way that we can have two values of f and s in here. So we can't have f and s in there. F and s must be in 2, 3, and 4, which means f and s can either be 2 and 3, or f and s can be 3 and 4. So what does that mean about x? We know that either one of f or s is equal to 3, which means that x cannot be equal to 3. So we figured out some possibilities, and now let's put it together. Let's go back to the sum in the third column. We know that we have a carryover of 2, x is not equal to 3, and we have 1 plus r plus 2t. What's the maximum value of this sum? This will happen when we take t to be the largest value, which is 8, and r to be the next largest value, which is 7. So the maximum value of 1 plus r plus 2t is 1 plus 7 plus 2 times 8, and this simplifies to be 24. So we know the maximum value is 24. We know it can't be 23 because x cannot be equal to 3. It could be 22. It can't be 21 or 20 because I and n are equal to 1 and 0. So 1 plus r plus 2t can either be equal to 22 or 24. Subtract 1 from both sides, and we know that r plus 2t is either equal to 21 or 23. Both of these are odd numbers. 2 times t will always be an even number. Now an even plus an even will always be an even number. So in order to have an odd result, we know that r must be an odd digit. But r can either be 6, 7, or 8, and the only odd digit is 7. So we know that r must be equal to 7. But if r is equal to 7, then t can only be equal to 7 or 8. We know that 7 is taken, so we have that t must be equal to 8. So we're really putting this all together. R is equal to 7 and t is equal to 8. We go ahead and substitute these in. We now have 1 plus 7 plus 8 plus 8, and that is equal to 24. So we know that x is equal to 4. So let's mark that in the column and let's put that into the sum. Since x is equal to 4, we know that s cannot be equal to 4, so we will eliminate the possibility that f and s are equal to 3 and 4. And the only possibility that remains is f and s are equal to 2 and 3. So f must be equal to 2 and s must be equal to 3. We substitute these in and we see there's only one unsolved digit, which is y, and that must correspond to the very remaining digit, which is 6. Therefore, y must be equal to 6. And we substitute that in, and we have solved the entire puzzle. 29,786 plus 850 plus 850 is equal to 31,486. And that is the solution to 40 plus 10 plus 10 is equal to 60. Amazing! Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems, one video at a time.